Let's go ahead and look at x minus 2 divided by x squared minus 3x minus 4. So let's just start with our x-intercepts. So we're going to make y 0. So we've got 0 equals x minus 2 over x squared minus 3x minus 4. We cross multiply and really just end up with that numerator equaling 0. So if you solve for your numerator equaling 0, you would get, after you add that 2 over, x equals 2. So x-intercept is 2, 0. Let's go over and solve for our y-intercept. So we're solving for y, we're making all of our x's 0. So 0 minus 2 over 0 squared minus 3 times 0 minus 4. So we get negative 2 over negative 4, which comes out to a positive 1/2. Vertical asymptotes, we're solving for that denominator, so x squared minus 3x minus 4. Check to see if we can factor it, because that's always, I think, the easiest method. We can, x minus 4 times x plus 1. You can always use the quadratic formula. So x will equal 4, x will equal negative 1. So those are our vertical asymptotes. You can draw them in if you'd like. 4 and negative 1. Horizontal asymptotes, looking at those degrees in the numerator and denominator. So we've got 1, which is less than 2. When that's the case, it's automatically at 0. Draw that in. So at this point, before I do the domain and range, I just like to go and see what the graph actually looks like. So let's go ahead and graph x minus 2 over x squared minus 3x minus 4. Remember, numerator in parentheses, denominator in parentheses, and then graph it. Graph the squared. So this is one of those cases where that graph goes through your horizontal asymptote. But if you're looking at it, again, it still has that alternating kind of pattern, like your two branches are opposite one another, even though that centerpiece goes through. So let's go ahead and try to graph that center section. I know that I've got a point at 0, 1/2, and x-intercept of 2, so I can draw that in there. Well, and this is just a sketch. And then let's find some more points for the left and right hand side there. So it looks like, well, let's do 2, 3. So negative 5. Okay, so now it's 0.25, 0.6. And right, there we go. And just draw that side. And then go over on the right hand side, try to get some points. So back to my table. So 5, 6, I did my whole left side backwards. These should all be negatives. Like, yeah, let's see. This is what happens when you have to keep switching back and forth. I can turn it. Not gonna work. Stop being lazy. So, poison. There we go. That's better. Okay, so hopefully it takes you a lot less time to graph that. So for your domain and range, your domain is always still skipping over those vertical asymptotes. So we've got 3 sections. That first section is from negative infinity to that first asymptote, which is -1. Then the middle section is from -1 to 4. That third section is from 4 to positive infinity. So for this one, for your range, guys, because it's going through that graph, your range is going to be negative to positive infinity. We're including every y value in this function. There's no values where it's skipping over anything. So for this one, when it goes through that horizontal asymptote, your range can be negative to positive infinity. If there's a gap there, like the one before, you'll have a U for your range, a union, or a gap.